20. Surgical strikes have been launched against Northern California's most vulnerable geological target in just 7 days. And the weapon is not human, it is the Earth itself, systematically attacking the foundations of Lassen Peak, California's most recently active volcano, and the southernmost major threat in a volcanic chain capable of reshaping the Pacific coast. What began as routine seismic activity has evolved into the most concentrated earthquake assault on an active volcanic region in recorded monitoring history. Each earthquake has struck with mathematical precision. All 20 events are concentrated within 50 kilometers of Lassen Peak, occurring at shallow depths of 3 to 5 kilometers that maximize surface impact, escalating from magnitude 4.7 to 4.9 over 48 hours, and affecting populations across a radius of 200 miles from Sacramento to Nevada. This is not random geological violence, it is systematic stress loading, targeting the exact geographical coordinates where earthquake energy poses maximum threat to volcanic system stability. USGS emergency monitoring has confirmed the volcanic connection that seismologists hoped would not emerge. Lassen Peak maintains a very high threat classification because of active magma chambers, proven eruption capability, and documented coupling between earthquakes and volcanic activity. The 2014 magnitude 3.85 earthquake near Lassen Peak triggered immediate destabilization of the hydrothermal system, doubling hot spring output and creating new steaming ground areas within hours. This is direct evidence that seismic activity can systematically disrupt volcanic equilibrium. Historical analysis reveals the catastrophic potential. Lassen Peak's 1914 to 1917 eruption sequence sent volcanic ash 200 miles across Northern California, generated destructive mudflows, and established this volcanic system as capable of affecting millions of residents across multiple states. Recent geological surveys confirm that earthquake-induced stress can create fracture networks that allow magma ascent, increase dissolved gas pressure that can trigger explosive eruption, and destabilize hydrothermal systems, creating secondary hazards. The 7-day timeframe represents unprecedented geological aggression. No active Cascade volcano has experienced sustained earthquake sequences of this magnitude and frequency since systematic monitoring protocols were established to prevent volcanic disasters. When 20 earthquakes execute precision strikes against a very high threat volcanic system in 1 week, systematically loading stress into magma chambers that last erupted within living memory. How close is Northern California to experiencing the first major volcanic crisis since Mount St. Helens 1980? And what happens when mathematical geological precision finally achieves the stress threshold required to reactivate a volcanic system capable of affecting 40 million Pacific Coast residents? To grasp the catastrophic potential unfolding at Lassen Peak, we must journey into the heart of one of California's most geologically complex regions. The Lassen Volcanic Center is not just another mountain, it is a restless giant with more than 825,000 years of eruptive history, a ticking geological time bomb situated at the crossroads of the Cascade Volcanic Arc and the earthquake-prone Basin and Range Province. This volatile intersection has created a volcanic mosaic of unparalleled diversity. The Lassen landscape is a kaleidoscope of geological features, the towering andesitic ruins of ancient Brokoff volcano, the dacitic lava dome field with its 30 separate volcanic vents, and the scattered basaltic shield volcanoes that hint at the complex magmatic plumbing lurking beneath the surface. At the heart of this volcanic labyrinth lies Lassen Peak itself, a dacitic lava dome estimated at 27,000 years old. It holds the distinction of being the southernmost major Cascade volcano. Its graceful symmetry belies the seething geologic forces that have shaped this region for more than 1 million years, the same forces that now threaten to transform picturesque scenery into a volcanic nightmare. Dr. Michael Klin, a volcanologist with the US Geological Survey, explains that Lassen represents the unique intersection of active volcanism and regional tectonics. Unlike typical cascade volcanoes that show clear volcanic versus tectonic earthquake patterns, Lassen sits in the transition zone where basin and range extension meets cascade arc volcanism, creating complex earthquake volcanic coupling that challenges standard monitoring protocols. But what makes Lassen truly terrifying isn't just its geological complexity, it's the hydrothermal time bomb ticking beneath the surface. The Lassen region hosts the most extensive hydrothermal system in the Cascades outside of Yellowstone, a labyrinth of fumaroles, boiling mud pots, and steam vents that serve as a constant reminder of the volcanic heat lurking just below the surface. Bumpass Hell, the largest of these hydrothermal areas, is a Dante-esque landscape of hissing gas vents and bubbling acid pools, where temperatures can reach a scalding 161 degrees Celsius and 322 degrees Fahrenheit. It is a surreal and alien environment, but one that offers a critical window into the inner workings of the Lassen volcanic system. Hydrothermal systems like Bumpass Hell are more than just geological oddities. They are direct indicators of the magmatic heat engine that drives Lassen's volcanic activity, says Dr. Laura Claw, a USGS research geologist. Changes in hydrothermal output, whether increased steam discharge or the formation of new mud pots, can serve as early warning signs of deeper changes in the volcanic system. And it is this delicate hydrothermal equilibrium that the current earthquake swarm is now threatening to shatter. Each precision strike, each shallow tremor, is systematically loading stress onto the same fault networks that control Lassen's labyrinthine subsurface plumbing. It is a geological assault that risks pushing this already restless volcanic system past its critical tipping point and into the realm of explosive reawakening. The current seismic siege at Lassen Peak is not the first time this volcanic system has demonstrated its vulnerability to earthquake-induced destabilization. Rewind to November 2014, when a magnitude 3.85 earthquake struck just 5 miles from the current December 2025 swarm location. That event, though modest by California standards, would trigger a hydrothermal crisis that offered chilling proof of Lassen's hair trigger sensitivity. Within hours of the 2014 earthquake, park rangers at Lassen Volcanic National Park noticed alarming changes in the hydrothermal system. Growler Hot Spring, a reliable barometer of subsurface activity, suddenly began discharging twice its normal water volume. Steam vents that had been dormant for years abruptly roared back to life, and ground temperatures spiked in previously stable thermal areas. As the USGS California Volcano Observatory scrambled to assess the situation, its monitoring network painted a disturbing picture. The earthquake had fundamentally altered the permeability of the volcanic bedrock, creating new subsurface pathways for superheated water to escape. It was as if the quake had punched holes in the plumbing of a pressure cooker, allowing scalding contents to rush to the surface. Dr. Kathy Janik, a USGS geochemist who studied the event, recounts that the 2014 Lassen earthquake sequence provided unprecedented documentation of real-time earthquake volcanic coupling. She observed immediate hydrothermal system response to relatively modest seismic energy, demonstrating that even magnitude 3 to 4 earthquakes can systematically alter volcanic system behavior when they occur at optimal depths and locations, relative to active magma and hydrothermal networks. The implications were sobering. If a single magnitude 3.85 earthquake could trigger such dramatic hydrothermal destabilization, what would happen if a larger seismic event, or a sustained swarm of earthquakes, struck the volcano? It was a question that would take on new urgency just a decade later, as the geological clock ticked down toward the December 2025 seismic siege. Fast forward to December 23rd, 2025, when the first tremors of what would become a relentless seismic assault on Lassen Peak began to register on California Volcano Observatory seismometers. At first, the earthquakes seemed routine. A magnitude 2.5 here, a magnitude 3.0 there. The kind of background seismicity that Lassen experiences on a regular basis. But as the days ticked by, a disturbing pattern began to emerge. The quakes were coming faster and harder, their magnitudes gradually escalating from the routine to the newsworthy. On December the 28th, 2025, a magnitude 4.7 earthquake struck just 9 miles northwest of Susanville, rattling homes and businesses across the region. Less than an hour later, a magnitude 2.5 aftershock hit the same location, as if the geological hammer had struck a second blow, while the anvil was still ringing from the first. By December the 30th, 2025, the situation had escalated to a full-blown seismic crisis. A magnitude 4.9 earthquake rocked the region just north of Lassen Peak, followed by a rapid-fire sequence of aftershocks that kept seismometers beeping like a geological Geiger counter. In total, 20 separate earthquakes had struck the volcano in just 7 days, a staccato burst of seismic violence that defied all historical precedent. Dr. Margaret Helweg, a seismologist at UC Berkeley, warns that the December 2025 Lassen County sequence represents the most systematic earthquake assault on an active Cascade volcanic center since instrumental monitoring began. She says we are witnessing mathematical precision in geological targeting that defies normal random earthquake distribution patterns, and that observation suggests fundamental changes in regional stress fields affecting volcanic system stability. But it was not just the sheer number of earthquakes that had scientists on edge, it was their uncanny geographical precision. Every single tremor struck within a radius of 50 kilometers of Lassen Peak, as if an invisible geological sniper was zeroing in on the volcano's bullseye. Worse, the quakes were concentrated at depths of just 3 to 5 kilometers, the exact range where they could impart maximum stress onto the volcano's fragile subsurface architecture. As the earthquakes marched ever closer to the 108-year-old lava dome, each tremor acted like a seismic battering ram, systematically loading stress onto the same fault networks that controlled Lassen's magmatic plumbing. It was a slow-motion geological assault that threatened to punch through into the volcano's molten heart and unleash the kind of devastating eruption that Northern California had not witnessed in over a century. As the new year dawned on Lassen Volcanic National Park, the hydrothermal features that had enchanted visitors for decades began to exhibit alarming signs of destabilization. Steam vents that had faithfully followed seasonal patterns for years suddenly started gushing, as if someone had turned up the pressure on a subsurface boiler. Mud pots that had once burbled quietly began to spit and hiss with renewed vigor, their bubbles swelling to the size of beach balls before bursting in explosive pops. But it was the changes at Bumpass Hell that truly set alarm bells ringing. The temperature of the acid pools, normally a scalding 80 to 95 degrees Celsius, 176 to 203 degrees Fahrenheit, spiked to an unprecedented 105 degrees Celsius, 221 degrees Fahrenheit, just a few degrees shy of the boiling point at Lassen's 8,000-foot elevation. Fumaroles that had emitted gentle wisps of steam for decades abruptly transitioned to roars like a jet engine, their plumes punching thousands of feet into the thin mountain air. As California Volcano Observatory scientists scrambled to deploy additional monitoring equipment, the data streaming in from the volcano painted a chilling picture. The earthquake swarm had systematically weakened the structural integrity of the hydrothermal system, creating new fracture networks that were allowing magmatic gases to escape at an accelerated rate. It was as if the geological fault lines were morphing into a circulatory system for the volcano's molten lifeblood, providing a direct conduit from the magma chamber to the surface. Worse, the GPS stations arrayed around Lassen Peak had begun to detect the first signs of ground deformation, a subtle but ominous swelling that hinted at the rising magma body, putting increased pressure on the overlying rock. It was a pattern that had been observed at other volcanoes in the lead up to eruption, a sign that the seismic siege was taking its toll on the volcano's deep architecture. The implications were clear and terrifying. The earthquake swarm had pushed Lassen Peak to the brink of eruption readiness, priming the volcanic system for the kind of explosive reawakening that could devastate Northern California. All it would take was one more well-placed seismic hammer blow, one more precision strike on the volcano's structural weak points, and the clock would start ticking down to a potential volcanic catastrophe not seen since the days of Mount St. Helens. Northern California's 7-day earthquake siege has achieved mathematical geological precision, systematically loading stress into Lassen Peak's volcanic foundations through 20 surgical strikes targeting the exact coordinates required for volcanic system destabilization. When sustained seismic assault transforms routine earthquake activity into precision geological warfare capable of reactivating dormant volcanoes, how long before mathematical targeting finally succeeds in triggering the first Cascade Range eruption since Mount St. Helens devastated the Pacific Northwest? Subscribe to Earth. Attacks for real-time updates on Lassen County's precision geological assault and the mathematical earthquake targeting that could transform California into America's newest volcanic emergency zone.